Hello, everyone. Welcome and hope everyone is having a great reinvent. Today, I'm Akshat Vig. I'm a principal engineer at AWS, and I'm here with Alman Gu, who is also a principal engineer at AWS. And today, we are going to talk about AWS Glue Elastic Views. So, in this talk, we are going to walk you through the journey of why exactly we decided to build Glue Elastic Views and what exactly is Glue Elastic Views, what specific problem it solves for you, how does it simplify creating materialized views on your databases that you're using for your application development. We'll also look at some of the key features that Glue Elastic View provides. And finally, we'll look at some of the power and control that Glue Elastic View gives you to materialize your, create materialized views. So let's jump into it. Now, if you look at any web application that you're developing, right, there are two pieces to the application development. One is the actual business logic that you're writing, which would be any of the code that you write. And second piece is the actual state of your application, whatever your application relies on. And typically, that state is stored inside a database. So let's take a specific example of an online shopping portal, right? So if you look at an online shopping portal, there are multiple sub applications inside that. So you need to have some way of sharing the product catalog with the users who are using your website. You need to have like order processing. When customers are placing order, you need a pipeline to track the orders that are placed. You need a pipeline to track the shipments that are being sent out, and personalization, analytics. So there are multitude of applications within that shopping portal that you build, right? And now what we have seen is that, and what we have heard from our customers is that one database doing all the things does not fit the use case at all. So in the sense that traditionally all the applications of order processing, personalization, analytics were done on the single database. But what we are seeing in today's world is that developers are building applications by breaking them into smaller chunks, and for each particular part of their application, as a developer, I would analyze what exactly are the functional requirements for my application, what are the performance characteristics that I expect from the database that I'm going to use, and whether that database scales to the requirements that I have, right? So once you have broken down your application, you pick the right database for the job that you're trying to achieve. And once now AWS provides you like a complete family of purpose built databases, which are like battle tested. Like a lot of applications are built on these databases, and they are highly performant, scalable, and secure. So now zooming back to the Apple online shopping portal example, if I have to build that for the cloud, then what would I do is I would pick the specific database for the specific need. So for example, if I'm doing analytics, I would pick Amazon Redshift. If I'm doing any of shipment tracking, I would use Lambda to process all the events which are coming from DynamoDB, right? So overall, development in today's world happens with using specific database for the job that you're trying to do. So you must be wondering why like this particular talk is about Glue Elastic Views and we are talking about purpose-built databases. So how does these two fit into the bigger picture? To understand that, let's zoom into a specific part of the shopping portal, which is product catalog, right? So as I said, if to build product catalog, I would start with what exactly are the requirements. I need to support, let's say we list them down. I need to support about 1 million users. I need to support request rate of 1 million RPS. And I expect that when I launch this application, I expect that, hey, all the requests that are being served from the data store, they are served in single digit milliseconds. And DynamoDB fits the bill pretty well. So I would use DynamoDB, configure my table, and I would launch that application. Now, let's say once the application is already running, now one more use case you need to add is hey, I want to support free text search on my data. So how exactly do I do that? Again, picking the right tool for the job, again, analyzing from all the different data stores that are available, I would pick Elasticsearch, because Elasticsearch provides you full free-form text search capabilities, right? So with that, my application would look something like this. I have my client application talking to a microservice, and that microservice behind the scenes is talking to DynamoDB for doing like order of one lookups from the product catalog, and any of the free form text search, and the application would be using, the microservice would be using Elasticsearch. Now, your product catalog is actually loaded in DynamoDB, right? So now, if you need to get part of your product catalog to Elasticsearch, then in today's world, there are few challenges that you have to deal with. One of them is I have to write complex application code to read data from DynamoDB and write it to Elasticsearch. I need to ensure that all the failure cases in the data movement are handled. I need to ensure that my pipeline, which is moving data, is always up and running, because my customers are now relying on on Elasticsearch and DynamoDB, the data to be in sync between the two, right? And then as the number of users in my application are increasing, I need to also make sure that the scale, how exactly my number of requests are scaling. I need to make sure this pipeline, which is moving data from one place to another, is also scaling. So Glue Elastic Views takes care of all that for you. Like, it makes it really easy for you to take data from the source and create a view on that data and materialize into a target of your choice. So just to recap, we looked at motivation, why we built Glue Elastic Views, essentially to simplify all the business logic that you had to write to move data from one place to another. So Glue Elastic Views is essentially, it's a service that helps you to combine and replicate data from across multiple data stores that we have, and then materialize them into the final destination. The key features of Glue Elastic Views are, one of them is it combines and transforms data. Like, with Glue Elastic Views, you can essentially combine and transform data and create a view to materialize it into the data store of your choice. Second being, it's easy to use. So as I mentioned, that with Glue Elastic Views, you do not have to worry about the hassle of configuring pipelines. You do not have to worry about writing thousands of lines of Java code or any code that reads data from the source data store and writes that data into the target data store. And with Glue Elastic Views, we provide an intuitive console experience so that you can just click a few buttons, and I'll show that in the walkthrough example that I have in few slides, that you can just click a few buttons and you can move data from your choice of source data store and materialize it to your choice of the target data store. Now, Glue Elastic Views also gives you full control. So what I mean by that is, to create a materialized view, you specify a view definition, and that view definition you specify using in form of like SQL-like queries. And Glue Elastic Views uses PartiQL for that. So what is PartiQL? PartiQL is an extension to SQL. It's open source, and it helps you define your views. And Alman has really interesting slides to cover more detail about the control part, the programmability part, and more details about PartiQL in the slides that will follow. And so basically, if you look at it, the ease of use and the control, Glue Elastic Views provides you the full spectrum. If you want a fully simple to use experience, you can just do button clicks on the console. Or if you want to be a power user or an advanced user who wants to control how exactly my Glue Elastic Views are materialized, you have the control, and we'll see that in the slides that follow. So Glue Elastic Views is correct. So one of the things with moving data from one place to another is that you have to ensure that it is correct, and this is one of the really hard challenges in making sure this is done right. And there are two parts to correctness. One of them is transactionally correct. That Glue Elastic Views, they have to be transactionally, like Glue Elastic Views ensures that the data that is moving from the source to the target is transactionally correct, in the sense that all the transactional boundaries, all the transactional semantics that are from the source data store, they are maintained when the data is materialized in the target. One more important point of being transactionally correct is ordering, right? So as your data gets written in the source data store, Glue Elastic Views ensures that all that data is applied in the materialized view in the same order, because if the ordering is not done correctly, then you get an inconsistent view. Finally, the second part of correctness is data transformation. Since we have, like, considering we support all like diverse data types because of diverse set of data stores, Glue Elastic Views has to ensures that the data is actually correctly transformed. And again, Alman will cover this in a lot more detail in his slides. Now, another thing about Glue Elastic Views is that it continuously monitors the source data store for any of the changes that are happening, and ensures that the target data store materialized views are actually in sync. So targets are kept in sync as the changes are happening in the source data store. Just like any other AWS service, Glue Elastic Views is secure. So all the data is encrypted in transit and at rest. And we also use AWS Identity and Access Management, IAM, to give you full control on how you want to manage access of the data. Glue Elastic Views, you pay for what you use. If you're doing one transaction, you pay for that one transaction. If you're doing million transactions, you pay for million transactions. And finally, it's serverless. Like, you don't have to worry about managing servers. It's highly available, just like any other AWS service, and it is fully scalable. Cool. So we looked at key features. Now let's look at, as I mentioned, it's easy to use. Let's dive a little bit deeper into that. And for that, the use case that we consider, that we are looking at, is, I'll zoom back into that, which is the product catalog, and we are moving data from DynamoDB to Elasticsearch. So I'll give a console walkthrough how exactly you can do that. So with Glue Elastic Views, things you have to do is, you first, assuming you already have a table in DynamoDB, what you do is you create a table in Glue Elastic Views, and then once the table is created, you activate it. Once you activate the table, the data actually starts flowing from your source data store into Glue Elastic Views. Next, you create a view. For that, you write particle queries that gives the view definition, and finally you click materialize, and that gets the data flowing into the target data store of your choice. For creating a table, as you log into the console, pick DynamoDB as the source. You will see the list of tables that exist in DynamoDB. So in this example, I have the product catalog. Now, if you want to, in this case, we are trying to materialize the product catalog. So you'll click that, create a table. If you'll notice that the table that you created is an inactive state. As I said, you have to activate a table for data to start flowing. So you click on activate button, the data starts flowing into Glue Elastic Views, and you'll notice that the schema of your of the data that exists in DynamoDB is also automatically discovered. Once you have the schema, you see that the table is active. You can create a view in Glue Elastic Views, and that you do by specifying a query. So in this particular slide, you see that you can write an SQL query to pick the attributes that you want to materialize in the target data store of your choice. So in this example, I'm picking out of all the attributes that I have in the product catalog, I'm picking the 5, like the product identifier, the name of the product, which will be useful in supporting the full text search. And once you have created your view definition, you can actually preview it. Like, in the sense that once you preview, what you see there is, out of all the data that is there in the source data store, in this particular example, what we are doing is we are just projecting out of all the attributes, I'm projecting 5 attributes. So you see that the 5 attributes will be finally materialized. So once you make sure your view definition is correct, you can go to the next. You click the next button, click on materialize, pick the data store of your choice. In this particular example, I'm picking the Amazon Elasticsearch service. You define the exact domain where you want to materialize your data. You give the name to the index and click materialize. Now, and boom, that's done. So now when you click materialize, like one thing which is important to notice here is that now DynamoDB has its own source data types, right? I mentioned that Glue Elastic Views takes care of diverse set of data types. How exactly it's doing that? So DynamoDB has its source data type. So in this particular case, we are dealing with strings and numbers, right? And a Boolean. Now, similarly, Elasticsearch has its own data type. So Glue Elastic Views gives you automatic suggestions that, hey, this data type should map to this. Or, so that's the ease of use. It automatically selects something for you, gives you suggestions. And the other part is that if you really want to choose something else, then you can go and choose the data type of your choice. So it gives you full programmability, full control over how exactly you materialize data from source to target. With that, I'll hand off to Almond to talk about programmability and correctness and walk through another example.
Thanks, Akshat. Next, I'd like to talk through how Elastic Views uses PartiQL to give developers full programmability and correctness. Elastic Views uses PartiQL's query language, an extension of SQL, to give developers full power to define their data transformations. It also uses PartiQL's rich data type system to represent all the data without any data loss or implicit data conversion. So let's zoom out a bit. AWS Glue Elastic Views has to interoperate with a wide variety of purpose-built databases as sources and targets. Different systems have different limitations, data types, and idiosyncratic constraints, and AWS Glue Elastic Views introduces the particle data model and query language as a sort of hub to cover all of these different type discrepancies. And this solves a real cross-product problem so that you as a developer don't have to deal with every point-to-point idiosyncratic detail of a source and target system, and therefore have to deal with this cross-product. And just to be clear, PartiQL isn't something we developed proprietary for AWS Glue Elastic Views. This is an open source and public specification. You can go and download it at particle.org. You can join the community and participate in open source if you like. So to talk a little bit more about how the data types in PartiQL cover all this diverse set of data sources and targets, because it's an extension of SQL, the sort of general SQL table works exactly as you expect. In this case, you can have rows with columns that have attributes that are scalar values. But the other thing that PartiQL introduces here is the ability to seamlessly work on document-oriented data. So if you're coming from DynamoDB, DocumentDB, or the like, you can see that nested data here is supported. But also, schema is optional. So if you don't have schema for some of these attributes with PartiQL, you can still operate on that data. So going back to the shopping portal example, let's imagine if the user wanted to perform some tax analytics on the tax analytical reporting on these orders. We're going to have to create a data pipeline in Elastic Views. So let's say that these orders are in DynamoDB, and we are going to want to get them into Elastic Views and do some normalization, transformation, combination, that sort of thing, to get the tax view that we want to operate on in analytics reporting. So we'll do that first, and then we'll add a step in the pipeline that does a transformation for data mapping. So this will do, the appropriately constrain the data so that it'll actually work in AWS Redshift. And so in this case, you can see we have two views in our pipeline, but views are a general purpose tool, so you could compose this in different ways if your application has more complicated requirements. So let's take a look at that transformation step there, that transformation view. In this case, we're going to create a view here that looks like traditional SQL. So if you've ever written a view in a traditional database, this should look very familiar. We're filtering cases where the city is Honolulu, and we're projecting some things and flattening out the nested record in DynamoDB. I want to bring back that order document that's in DynamoDB as an example here, because I think there's something really important to illustrate of particle query language's power here. So you can see in this case that line items is a field here, but in DynamoDB there's no schema for this field, so it's just there, and we're able to access this. In addition, we're flattening out a nested data structure, so we're doing a join directly on this nested data. So going back to the transformation, you can see that I've highlighted here that the join is being done directly on this correlated variable. So this is how we're flattening, and we're accessing that nested field that doesn't have schema directly, just seamlessly in the syntax. And if you're familiar with nested data or unnesting data in other databases, you might notice that this extension would be a cross apply or an unnest keyword. But in Particle, we're able to just model that as a comma cross join here with a correlated variable. So let's take a look at that transformation view and some example data. You can see here that we have the city of Honolulu, so this will be in our view, and these line items are getting flattened out to 2 records from the original order. And in this case, you see all of those nested fields for the SKU, the quantity, and the price getting projected, but we also have the tax computed here as well. So next step is to deal with this data compatibility. It's nice that we have a nice logical view for analytical report, but DynamoDB has different types than Redshift does. So we're able to cover this in Particle. So DynamoDB's number type is a decimal in Particle that has a floating precision and exponent, and also no trailing zeros. DynamoDB's string is also a string in Particle, but it has a byte length constraint of less than 400 kilobytes, the size of the record. So we're going to have to make some choices in Redshift explicitly about how we want this data to map over. So because Redshift doesn't have a floating decimal, we have other number types in Redshift. There's integers, there's binary floats, and fixed point decimals. In this case, I chose an 8-byte integer for the order ID. I also chose a 4-byte integer for the quantity, and then I chose some fixed point with 2 decimal places for the price and the computed tax. Also note that we don't have a string that can be up to the same large as DynamoDB, so I chose a variable length string in Redshift for that. That's 65K, the maximum. Again, though, it's important that this hub type system is covering all of these cases. And these types are particle types too. We have the integer with the different constraints. We have strings that are modeling this constraint. We also have those fixed point decimals, especially because it's inherited from the SQL data model. So you can see that we can cover both type systems with Particle. We just have to be very cognizant about how we want to map. It gives you that control to get that data mapping exactly as you see fit. So let's take a look at, based on our decisions here, the kind of mapping view we want to create. So again, it's going to be a view in Particle. We're sourcing this view from our transformation view that we made earlier. And we are putting some cast here to do conversions to those types that we chose. And again, it doesn't matter where the data is coming from. We're using one type system. So Particle is covering these data conversion cases. In other systems, you might have to write some custom Java code or Python. We don't have to do that here. We have a query language that can cover those cases. And also note that we can have type aliases that can cover those constraints, like this rs varchar max, which underneath the hood is bound to a type that is the string with that constraint. Other databases may have different constraints, like for example, the traditional character strings have code point or character length limitations, but these databases that we're having in our example are working on byte lengths. So let's take that input, the output from our transformation view, and run it through that mapping view that we created. You can see that everything kind of comes out one-to-one as you would expect, and we've done some, you can see also that there's some subtle changes with the order ID and quantity. Those became integers, the prices, and the price and the tax also became 2 decimal places of precision there. So we've modeled that conversion pretty nicely with this view. But with the power of DynamoDB is a very flexible system. It gives us the capability to have schemaless data with nesting. So what happens if we have unexpected data? So again, with our shopping portal example, we could have had a system that accidentally, well, or intentionally, depending, put some binary data into the DynamoDB record for the SKU instead of the Unicode string. Well, in that case, it would be really great if we could capture those exceptional cases, either for unexpected, conversion loss, or whatever constraints I as an application writer need to deal with, and put that into another, materialize that into another view. And in this case, maybe let's put that into S3 so we can do some operational analysis if any of these cases come through. Again, we can leverage the power of PartiQL's query language to create yet another view here. So this is a view that we're sourcing over the transformation view, and we're adding some predicates into the filter and the projection to only get those records that don't quite fit our expectations. And in this case, it's arbitrary particles. So the full power of the query language is available to you. It doesn't have to be just this, but it can be as complex as it needs to be. Again, it's just another kind of view. So taking a look back at our now updated pipeline, we have this transformation view that we've created to combine and make the data logically the way we want. We've added this violation view to capture sort of these unexpected or exceptional cases and materialize them into S3. And we have our data mapping view to precisely control how the particle data coming from DynamoDB gets modeled in our Redshift database. So all of these are just view compositions, and you could, depending on your complex application requirements, do different things. So let's, I've been talking a lot here about the power of the particle query language and all of the rich data typing, but I want to take a step back and note that easy is not an either or here. Akshat demonstrated a really nice seamless user experience through the console. And I want to point out here that that console is powered underneath the hood by all this particle data typing and particle query logic. So you can get that benefit from the streamlined user experience, but if your application has more stringent demands on the data transformations or the kinds of things you want to do, you can always get in there. So you can get that nice 80-20 of the benefits of the streamlined experience combined with the full power of the type system and the particle query language. So just to recap what Akshat and I talked about here, we gave some great examples about how you can go from your operational store through AWS Glue Elastic Views and materialize that data in a diverse set of target systems. I want to give you a sense for what's coming up in the next year. And our goal here is to cover our portfolio of database services. Our goal is to also support enhancing Particle to meet the needs of our customers, such as joins and aggregates. But importantly, we really want to listen to feedback from our customers during this time and prioritize and deliver on the features and integrations that will deliver the most value for our customers. So hope you're as excited as we are about this offering, and join our preview to find out more. With that, on behalf of Akshat and myself, I just want to say thank you very much for attending this talk, and I hope you have a great day. And please complete the session survey to give us feedback on this talk. Thank you very much.